Okay, for the next part, we're going to talk about differential equations again. Differential equations are basically derivatives. And remember this from earlier, dy dx equals, this is what dy dx equals. That means the change in y over the change in x. And if the question asked you to use separation of variables to find what y was. So first off, you're probably wondering what separation of variables is. Separation of variables is basically, it's a concept you're going to be talking about a lot later in the differential unit, but you have to use it now. And it's basically the fact that you can't just take the integral of this because there's no d anything over here. So what we have to, because an integral, remember, this doesn't make any sense. This is improper form. You don't know what you're taking. You could be taking this dy, and then you wouldn't be able to do anything. It wouldn't make any sense. So you would have to put a dx at the end of it. So for that reason, we can't just pop in derivative things here because there's no d anything here telling us what to take the derivative in respect to. So what we have to do is multiply the dx over here and separate the variables. So we get dy equals 9x squared over the square root of 1 plus x cubed dx. And now we can put integral signs here, and we can take the derivative, or sorry, the integral of these. The integral of dy would be the same thing as the integral of 1 dy. If you're taking it in respect to y, though, then the derivative of this would be y. And that's what we're looking for, so that's very nice. But this is the part that's going to take us a little bit longer. What thing do you think we're going to have to use to find this out? Use substitution. So we know that the derivative of 9x, or I'm sorry, the derivative of x cubed equals 9x, or equals 3x squared. But because there's a square root here, that's actually going to play to our advantage a little bit. I'm sorry, give me 1 second, my phone just went off. And I'm waiting for something really important, so. Okay, sorry about that. Anyway. So in this case, u equals 1 plus x cubed, and then du equals 3x squared dx. And now that we have that, we can kind of plug this into our equation right here by thinking little arrows. 3x squared dx. We have the dx, but the 3x squared we're going to have to put a 3 in front of, so it'll be 3u, because we want to multiply that by 3 to get the 9x squared dx. So yeah, right? Wait, I'm like I'm spacing out all of a sudden. Yeah, okay, that makes sense, because then if you multiply this by 3, you get 3 du equals 9x squared dx, which is what we want to plug in here. So you have to put 3u, I'm sorry, I am so out of it right now, 3, and then there'd be a du right here. So 3 du over the square root of u, because that's what we have in the original thing, which would be the same thing as the integral of 3u to the negative 1/2 du. So we would bump this up 1, so it would be u to the 1/2, and then multiply by the reciprocal of that, so it would be 6u to the 1/2 plus c, and 6u to the 1/2 plus c is the same thing as 6, and then we'll put in parentheses the 1 plus x cubed, the 1/2, or you put a square root over that, plus c, and this equals y, because that's what we got on the left side. So that would be solving for y, starting with a differential equation. You have to separate the variables.